In this video, we're going to prove properties using congruent triangles and CPCTC. Remember that CPCTC stands for corresponding parts of congruent triangles are congruent. That means if we already know that we have two triangles that are congruent, then we know the parts that are corresponding are congruent. So let's look at a couple of proofs. In this one, we want to show that segment KR is congruent to segment AY. And we're given some pieces to begin with. So we're given that KY and RA are congruent. We're also given that KY and RA. In order to show that those parts are congruent, we need to show that the triangles in this picture are congruent first. Once we know we have congruent triangles, then we know the corresponding parts will be congruent. So our goal in this proof is to prove the triangles congruent first, and then we'll know the parts. So we'll start out with our given information, that KY is congruent to RA and KY is parallel to RA. We also know in this picture we have that shared side RY. So RY is congruent to RY by the reflexive property. Now the parallel lines in this picture are KY and RA, and then we have the transversal RY. Having those parallel lines and transversals actually give us some angles that are congruent. We have those alternate interior angles KYR and ARY that are congruent by the alternate interior angle theorem. So now that we know we have a side, an angle, and a side in each of those triangles, we know by SAS congruence that those triangles are congruent. Now that we've shown that these two triangles are congruent, we now know all of the corresponding parts are congruent. Therefore, we can say KR is congruent to AY by the property of corresponding parts of congruent triangles are congruent, or abbreviated CPCTC. On your notes, what I'd like you to do is have the two-column proof, but I'd also like you to create a flowchart proof based on this problem. In the next example, we're given that LU is perpendicular to KU. That's going to give us a right angle here. We also know that YK is perpendicular to UK. We also know that C is the midpoint of LY. That's going to make these two pieces congruent to one another. We want to be able to prove that LU is congruent to KY. In order to do that, we have to show that the triangles are congruent. We have to show that the entire figure is congruent before we can show the parts are congruent. So we can see here, we'll start out with our given information that we have those perpendicular lines and that C is the midpoint, and then we'll start with those implications of those statements. We'll know because those lines were perpendicular that angle LUC and angle CKY are right angles by the definition of perpendicular lines. We also know that we have a set of vertical angles here. So the set of vertical angles are angle LCU and KCY. We also know that segment LC is congruent to segment YC by the definition of midpoint. Now look at the sets of triangles. We have an angle, and then a side that's not between them. That's congruent to an angle, and a side that's not between them. So we could prove these triangles congruent by angle, side. It's worth noting also that because we have those right angles, we could also use HA congruence for this set of triangles. Now that we know our two triangles are congruent, we then know all of the pieces are congruent. So those pieces that we were trying to show were congruent, LU and YK are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. I'd also like you to develop a flowchart proof for this proof, and I'll be checking those when we do our notes check. I have this proof that I'd like you to start from scratch. You're given KN bisects angle EKO, and that KN is perpendicular to EO. We want to prove that KE is congruent to KO. So think about how you could prove those triangles congruent first and then show that those pieces are congruent. The last example is where JN is parallel to AM, D is the midpoint of JA, and we want to prove that ND is congruent to MD. A hint on this one is that you have to decide which set of triangles would help you show that ND is congruent to MD. Once you've shown those triangles congruent, you can use CPCTC to prove those parts are congruent.